Here we are going to explain how we can solve the gambling model. Let me first write down the Bellman equation. The Bellman equation, what we have is Vn of x is equal to maximum, and we have y between x and 0. That's the bet. Y is the bet. And then we have p. This is the expected value, n minus 1. If we win, we have x plus y. If we lose, with probability 1 minus p, we have Vn minus 1, x minus 1. Right? So that's the problem we are trying to solve. And v of 0 of x is equal to log of x. Okay, so that's what we have. So now let's try to first solve v1. And after we see a pattern, then we're going to use the induction to find v sub n of x. So using the Bellman equation, we have y less than or equal to x. That's the bet again. And p and v0 and x plus y and plus 1 minus p and Vn minus y and x minus y. Okay. So now we plug in the function, and that's going to be maximum y is less than x, bigger than or equal to 0, and replace x by x plus y. We have log x plus y and plus 1 minus p and log x minus y. Now, at this step, we are going to make a change of variable. We are going to call over here y, this bet, is equal to alpha x, and alpha is less than 1, bigger than or equal to 0. You may ask why we do this. This is an afterthought again. You will see the advantage of doing this. So if you look at this, alpha is really the ratio. Alpha is y over x. That's the bet over the total amount you have. Okay. So the reason we make this change is that now we can say this maximization is over alpha between 1 and 0. You see, there is no more x over here. And here we have p and log x plus alpha x and plus 1 minus p and log x minus alpha x. And this is really convenient because we use the property of log x, and this is what we have. We have p, and we have log. Here we have the product, x1 plus alpha, and then plus 1 minus p, and log over here we have x1 minus alpha. So we factor x out, and then we apply the property of logarithm, and we have over here we have p log x plus p log 1 plus alpha and plus 1 minus p log x and plus 1 minus p log 1 minus alpha, right? And then look at these two terms, p log x and 1 minus p log x. If we add them up, we have exactly log x. So now we have over here maximum alpha between 1 and 0, and then we have log x over here and plus p log 1 plus alpha and plus 1 minus p and log 1 minus alpha. Okay. Now if you look at this maximization problem, log x is independent of alpha. So we can actually get log x out because it's not changing. It's simply a constant, right? And then we have alpha between 0 and 1, and p log 1 plus alpha and plus 1 minus p log 1 minus alpha. Now, if we look at this problem over here, this is a pure calculus problem. It has no x anymore. It's just about alpha. But also, we have a parameter p inside. And so now we can isolate this problem out and solve this one. So what we're going to do over here is that we say, all right, we're going to let f of alpha, which is just, for convenience, we say, okay, this is we have, and p is just a parameter. So we put it over here. And then we look at the first order condition and take its derivative. Okay. And we have 1 minus p, 1 minus alpha. Remember chain rule, so we have -1. And we set this to 0. Okay. And we try to solve it, and based on experience, this is the fastest way to do it, just to move the negative term to the other side. And we also know this is the balance between bet $1 more or less. So